today's topic is about geometry. Okay, let me quickly go over the formulas for rectangles. In pre-algebra, you already learned the formulas for the perimeter and for the area, right, of the rectangle. Well, the perimeter, if we denote the length by L, the width by W, right, and then the perimeter, is going to be 2L, right, plus 2W. Right. Well, why 2L, 2W? Because there's a two, 4 sides here total, right? 2 identical sides. Okay, L, and it's the top one and the below. And the area, we also introduce the form, right? The area, this is definition, okay? The area is going to be L times W, okay? So the length times the width. Now, if this actually tells you the geometric meaning of the area is, if the length is 3, for example, the width is 2, and 3 times 2 is 6. 6 means you have a 6 unit square inside. So that just tells you how large of this piece of, for example, if it's cake, how large of this cake, okay? So that is the area. Now, another one, well, it's called the length of the diagonal, okay? The length of diagonal you have to use as a D, okay? You have to use a Pythagorean theory to find out, right? Pythagorean theory is that this is the hypotenuse of the triangle. So D is going to be square root of L square plus W square. Okay, so those are the basic formulas. And we are going to use those formulas. The last one is the Pythagorean theory, basically, okay? And so if you know the width, if you know the length, then you can get the length of the diagonal. All right. So let's take a look at the following problem. A rectangle has an area of 27 square meters, and the length is 3 times the width. And what is the perimeter? Okay. So to solve this type of problems, you need you have to step 1, you draw the picture, right? I already drew it for you. Step 2, you need to mark in the label it, right? So the length denoted by L, the width denoted by W. Okay. And you write down the formulas involved in this problem. Okay, first of all, you talk about area, so you write down the area formula, L equals L times W. Okay, so now another condition called its length is 3 times width. Okay, the length is 3 times the width. Okay, that's all you need. All right, so after you get that, you want to find out what? You want to find out, oh my God, you want to find out the perimeter. It's 2L plus 2W, okay? So basically you want to find L and W, but if you find the W already, you can get an L by the above formula. Now, how can I get the W, the width? How can I get W? Well, use the given information, 27. So the area, you see, area is L times W. I have 2 variables there, 2L and W. So I need to replace, LW, right? So L is a 3W. So that's a 3W and the times W, right? So it's going to be 3W squared, okay? Right? So you can express the area in terms of 1 variable, which is W. Then this is going to be 27, okay? So now you get a simple equation. So 3W squared equals 27. So W squared equals 27 divided by 3, which is 9. Okay. Now some number square is 9. You know what is that, right? Because 3 times 3 is going to be 9. So W is going to be 9. It's going to be 3. Okay. Now W is 3. That's also implies because length is 3 times W. So it's going to be, length is going to be 3 times 3, which is 9. So once you get the width and the length, and you can get the perimeter. Okay, right? You can get the perimeter. Okay. Now, yeah, I did this problem first, and so the parameter is going to be 2L plus 2W. Now you can take a 2 out. I guess L plus W, so 3 plus 9, and that's gonna be 2 times 12. It's 24. Okay, so you write down answer, and you can say answer is 24. Okay, and don't forget the units, because when you say the meters, they have to put the meters. Okay, you have to put the meters there. Okay, that's the end. Okay, so that's how do we solve the problem. Write down the formula you need it, and then write down the given information. Okay, and then you try to solve those equations you can get. Okay, step by step. Right. All right. So here's another problem. I want you to try first. Okay, if you get answers, you post it to me privately. You can click in the chat window. You click my name and send the answer to me. Okay, and don't be don't be shy. Okay, if you have answers. Okay, you should yeah, take a piece of paper and pencil and work on that. Okay, first of all, you draw the rectangle as I showed to you, and you label them W, L, and W. Okay, so this time you are given the parameter. Okay, and you also given information the length of the rectangle is 3 times the width. Okay, what is the area? So in order to find the area, you have to find you have to find the width and the length. Okay, can you do that? So you first of all, you write down the formula you need it, right? So the formula, right? So let me finish the formula. Yeah. So formula, it involves the area, so it should be L times W. It also involves the parameter. So it's 2L plus 2W. Okay, what we are given? We are given the following information. Length equals 3 times the width. Okay, we also given the parameter equals 96. So those are the given information. What do you have to find out? You want to find out the area. Okay, so that's what I want to write. Okay, if you do the homework, when you do the homework, yeah, you need to express it clearly every step. So you see so let me emphasize the 3 purposes of studying mathematics here. Step 1, we want to enrich our knowledge, which is required for the middle school. Okay, and you want to learn all the topics. You don't want to skip it. Okay, but that happened in the school. Okay, school cannot cover all the materials. Number 2, we want to improve our problem solving skill. Okay, that's also, we have to solve some a little bit difficult problems, challenging problems. Okay, number 3, the purpose, number 3 is to learn how to express mathematics clearly. Okay, and that is not also always very covered. It's not always covered in the school because teachers are so busy. They can only check the answers. They don't want to have time to check the details of the work. That's very important skill. So I want to, if when you do the homework, you have to show step by step. Okay, not only just to show me the answer. So okay, so you write down that what is given and what is that. Okay, now from here you combine, because P is 96, so it's 2L, L is a 3W, right? And plus 2W, that's gonna be 96. Okay, so actually you're given 2 equations here. L equals 3W, P equals 96, and then you then here you get yeah, so you get 6, right? And 8W equals 96. Then you get W. Okay, so W is going to be divided by, it's actually is going to be 12, okay? W is 96 divided by 8, okay? It's 12. Okay, so once you get 12, then L is going to be, 3 times W. So it's 12 and 36 step by step. So if we make mistakes, and the teacher can see which step you make mistakes. So the area is going to be LW. So L is 36 times W, and W is 12. Okay, it's a 432. And don't forget to put the units there. Good job. Okay, I see all the answers posted there. It's correct. Not everybody posts answers, but I wish you do that. Okay. All right. Now our next problem, I have to need to show to you. Okay. The next problem is about the percentage problem. Now we increased by a certain percentage. Okay. So read the problem carefully. Okay. We have to understand what does that mean? Increase by 3%, by 5%, by 6%. Okay. Let me write down something here. If you have a quantity Q, okay, if it's increased by R%, means Q plus R%, R plus over 100 times Q. Okay, so that increased by R%. Okay, and if Q minus Q changed to R over 100 divided by Q, that means decreased by R%. Okay, decreased by R%. Okay, so that is a formula or whatever called definition. Okay, we should know that. Okay, so now, okay, this is L, this is width, and now L is changed to L prime, width is changed to W prime. Okay, so what we are given? Okay, we are given the information. The width is the length is increased by 20%. Okay, so L prime equals 20%. L plus 20 over 100 divided by L. Okay, so L plus 0.2 L, and if you combine them, it's going 1.2 L. Okay, that's the relationship between the new length compared to the original length. Okay, so the width is decreased by 20%, right? So you subtract this quantity 0.2 times W. Okay, so now you will get W minus 0.2 W, right? Which is going to be 0.8 W. Okay, so that's a relationship between the new width and the original width. Now let's do the multiplication. So we want to see how much the area changed. So A prime is the new area, right? It's going to be L prime, W prime. We don't know the original length. We don't know the original width. Okay. So L prime is replaced by 1.2 L, and the width is replaced by 0.8 W. And we do the multiplication. Okay, now you can try. Okay, you do the multiplication. And you multiply this out. 1.2 times 0.8 is 0.96 LW, but LW is original area. Okay, so you can see the relationship between the two areas. The new area actually is smaller than the original area. All right, smaller. That means decreased, right? The question decreased by what? So it's decreased by 0.048. Okay, right? Because if we subtract 0.04 from 1, you get 0.968. So this is a decreased part. Okay, now by what percent? By 4%, right? So then you can say that decreased by 4%. Okay. That's how do we solve the problem. You don't need to know the original length. You don't need to know the original width, but you still have to introduce those two variables. Okay, you still have to introduce the. So it's not necessary to specified. It's interesting, right? The length increased by 20%, the width decreased by 20%. Without do the computation, you probably will believe that the area is not changed, but turns out to be the area will be changed based on the math computation here, right? The area is decreased always. So if you increase the length, decrease the width by the same percentage, you always decrease the area. That is interesting phenomenon, right? Without doing this computation, we don't know. So sometimes, yeah, we need a mathematics to get some conclusion we usually cannot get from the experience, as you can see, right? All right, then we solve the following problem, trying to solve the following problem. If the length of the rectangle is increased by 10%, I know if I decrease the width by 10%, the area will be decreased. So I want to know decreased by what percent the width. The area still remain unchanged. So I think before we do solve the problem, I believe that the width should be decreased a little bit, not 10%, maybe 9%, maybe 8%. So the area still remains unchanged. If it decreased by 10% or more, the area will be less than original one. That's what we already see that. So get common sense. So when you get the answers, you should know this number is small, smaller than 10%. Okay, decreased by smaller than some, 10, maybe 3 or maybe 6, maybe 7%. Okay, now this problem is a little bit difficult than the previous problem because you do need to solve an equation. Okay, so let's see. It's width, length, that's width. Length, that's width. Okay. So we name the variable. This is a solid problem. By what percent? We say R%. Okay. I want to find R. I want to find R. So what we are given? We are given L prime equals L plus 10%. Okay, it's 1.1 L. Okay, that's a relationship. And W prime is going to be W minus R over 100 times W. So now this is not clear. So I just say 1 minus R over 100 W. Okay. That's my hint. Can you continue? So you want to make sure the area remains unchanged. So what is R? Can you solve for R? If you know how to solve a linear equation, you're able to solve it. Okay. So let's do this. I'll give you a hint. You want to make sure A prime equals A, right? Area remains unchanged. So from here, can you get the equation in R? And you solve for R, okay? That's my hint. Okay. Anyone can post the answer to me? You probably need a calculator to do some decimal computation. Okay, yeah, this is a little bit difficult than the other problems, right? Because you have to solve the equation. It's not like a direct computation. So how? Okay, let's look at A prime. A prime is going to be L prime W prime, right? It's a product of the new length and new width. So that's 1.1 L times 1 minus R over 100 W. So it's 1.1, 1 minus R over 100, and LW. LW is A, right? So that's A. So this should be equal to A means, let's go to this space here. It's 1.1 times 1 minus R over 100 equals 1. So you just need to solve this equation, okay? To solve this equation, what are you going to do, right? This can be, and 1.1 is 11 over 100, okay? So, so 1 minus over 100, and that is going to be 1 over 1.1, right? Okay. Okay, right? And from here, you solve for, you can multiply by 10. So this is going to be actually 1 over 11. Okay, I hope you understand that. Okay, so I is going to be 1 over 111 times 100, and then about 9.09. Okay, so it's close to 9%. So that means you have to the width decrease by 9% or slightly, around 9%. So you can keep the area unchanged. Okay, it's not 10%. If it based on above computation, if it decreased by 10%, then the area will be decreased, definitely. Okay, so sometimes we have to solve an inverse problem. We know the answer. We want to figure out what is a percentage by which the width should be decreased. Okay, so in order to keep the area. So this is a little bit difficult problem. Okay, So let's move on to the next one. For this problem, I needed to know a little bit information about the coordinates. Okay, so if you are on the XY plane, okay, a point, every point is one-to-one corresponds to a pair of numbers, and usually it's called A and B. So where's A from? A from here. Where's B from? B from here. So if you give me a pair of numbers, I can uniquely determine the location of the point. We'll call the name of the point is P, and AB are called the coordinates of the point. Okay, so that is a quick review on the coordinates, on the coordinate geometry. Okay, we use algebra to study geometry here. Okay, so now you have a rectangle. Okay, you have a rectangle in the coordinate XY coordinate system. So that is going to be the coordinate system will be here. Okay, this is the x-axis, this is y-axis. So our first point here is going to be 2 and 3. So that means if from here, this point is 2, and this point has coordinate 3. Okay, right? So 2 plus n, 2 and n plus 3 is here. You see, 2n plus 3. Okay. And another one will be 2n and 3. I think it's here. 2n plus 2 and 3, because 3 is the same height, right? The y coordinate is 3. So it's on horizontal line. And then the other one is 2n plus 2 and n plus 3. Okay. So a point, 2 points have the on the same horizontal line, means their second coordinates should be the same. So that's why n plus 3, they have the same. Okay. So then you label all the points. You write down the coordinates for each point on the rectangle. So then you will see the width and the length. So the length in this case is from 2 to 2n plus 2. So the length actually is 2n plus 2. The difference of those two numbers, which is 2n. Okay. The width is going to be the difference of their second coordinates. We call the y coordinates. That's going to be n. Okay. So once you figured out that, then it's easy to solve the problem. So the area is going to be width times length times width, 2n times n. That's going to be 128. Okay. 128 divided by 2 is going to be n squared, right? Divided by 2, 128 divided by 2 is going to be 64. And that's why n should be equal to 8 because n squared equals 64. Okay, so you solve this problem. Now, this one, you need some knowledge about the coordinates of the point in the xy plane. Okay, and the first coordinate comes from the x-axis. The second coordinate comes to the y-axis. Okay, the vertical line. Okay, and then you can solve this problem. You have to figure out the length of the rectangle and the width of the rectangle in order to solve this problem. All right. Okay, so let's move on. This is the only problem involving coordinate geometry. Now let's talk about triangle. For a triangle, the most important triangle is a rectangle triangle. Okay, rectangle triangle. Okay, usually put a note here. It's it's called it's a right angle here. It's a 90 degree, and they have two legs, A and B, right? And then C is the hypotenuse. The Pythagorean theorem says that it is a right triangle if and only if C squared equals A squared plus B squared. Right. Now, what does that mean? If and only if? That means if it's a right triangle, then C squared equals A squared plus B squared. Now, if C squared equals A squared plus B squared, then it must be a right triangle. People usually don't pay attention to this converse statement. Okay, and actually, this is the complete statement of Pythagorean theory. Is a back forward. Yeah, it's a two direction. Okay, so for the right triangle, and this is a 3, here's a 4, and this is a famous one, right? 3 squared plus 4 squared equals 3 squared plus 4 squared equals 5 squared, right? Okay, there's lots of other special right triangles there, and with the integer lenses. Okay, well, I think that's the one we can have. Okay, let's think about. And this side is 12, and this side 13, and let's figure out the other side, right? 12 square. Yeah, this is we don't know, right? It's 8, right? We're trying to figure out what is a square. A square plus 12 square equals 13 square, right? And then a square equals 13 square is 169. 12 square is 144, right? And the subtraction is going to be 25. Okay, so A is going to be 5. So you get another special right triangle with all the integer lenses, right? That's good. All right. Now I'm going to consider a special triangle, and which is this is a 30 degree, and that should be 60 degree, and this is 90 degree. Okay, so this triangle, I want to find the relationship between the A and the B and the C. Okay, A and the B and the C. So I put it into here, duplicate. Okay, clone it. Okay, so I get C here, and this is a B, this is a A. Because this is 60 degree, right? And here's 30 degrees, so double it, it's also 60 degree total. So what do you get? You get an equated triangle. So if you get equated triangle, the bottom part is going to be 2B, right? And this is C. So this is the equated triangle. So immediately I have a C equals 2B. Okay. In other words, B equals half of C. Okay, that's the same. All right, I know I want to find the relationship among those three, between those three sides. A special right triangle, 30 degrees, 60 degrees special triangle. We're going to use that. Okay. Yeah. So can I express A in terms of C? Then you have to apply the Pythagorean theory because it's a right triangle. So A square plus B square equals C square. All right. So A square, B is half of C already. We already know that. So from here, you can solve for A. Let's solve it. Okay. So A square equals C square minus 1/2 square is a quarter. Then you do subtraction. 1 minus quarter is going to be 3/4. And from here, you will get A equals square root 3/4 and the C square. Now, after simplifying, you get square root of 3 and 2 and the C. Okay, so that's another relationship. We have a two relationship here, A and the B. Okay, for the 30 degree, 60 degree triangle. Okay, that's the application of Pythagorean theory. Okay, so we should know this formulas in order to, many, there are many problems involve the special triangles, special angles. Okay, so you can use that directly. You don't need to repeatedly do the computation. Okay, so here's the problem. Okay, if the edge length of the equated triangle is 10 units, what is the area? How do you find the area? Right, remember, for the area of the triangle, if this is a height, this is a base. So the area, you write on the formula, half of B times H. I know what is a B, right? But I don't know what is H. That's a key point. Yeah, that's a problem. We know that B equals 10. That's a given information. So what is H? How do I find it? If I can find H, I can find the area. So that's my question. And I'll let you to think about first. Okay, once you find the H, then you can find the area, right? Now, equated triangle means all the angles are 60 degrees. Because the sum of three angles is going to be 180 degrees, right? That's what we learned from pre-algebra.
Unknown caller.
Okay, so look at this special angle, right? Triangle. So B is this is going to be B also. It's a B, right? It's a B. Okay, it's a 10. This side is 1/2, half of a, right? Half of 10. It's going to be 5. And the other side, as you remember, 3/2 times 10, right? So H actually is a square root of 3 times 10. It's a 5 square root of 3. Okay. 5 square root of 3. Okay, so once you get H, then you can find the area. Here is half of B, 10 square, 5 times square root of 3. Okay, so it's 25 and the square root of 3. So that will be the answer. Okay, that will be the answer. Yes. So the height is a square of 25, but it's simplified. Yeah, square root of 75 is going to be square of 3 times 25, and then the square of 3 times 25, and that is going to be 5 times square root of 3. Okay, yeah, you should apply the formula directly to don't use a Pythagorean theory, just use the special angle, a formula for the special triangle. Okay, then you can quickly get the height, and then you solve the problem. Okay, great. Now let's try to figure out the area of the parallelogram. Parallelogram, yeah. How do we find the area of the parallelogram? Okay, if this side is a B, okay, and the height is h, you know, some of you say, I remember the formula, right? But how do you find the formula? The idea is very simple. You move, you cut one triangle here, you move it to here. So what do you get? You get a rectangle. So the parallelogram is going to be, the area of the parallelogram is going to be the area of the rectangle, which is going to be, this is a B, right? And then, yeah, you move this to here, and you make a rectangle. So it's going to be just a B times H. Okay. If you know the height, if you know the base, and this is the area of the parallelogram. Okay. So the first, for example, it doesn't matter how big, you know, this is a 5. If you know the, yeah, let's do one problem to understand. Okay. So if this side is a 60 degree, okay, this is a parallelogram. What is the area? Okay, what is the area? Well, to solve this problem, this is a parallelogram. Okay, we assume that. Otherwise, we cannot solve the problem. Yeah, it is parallelogram. Okay. Right. So all you needed to do is to find the height. If you know find the height, yeah, then you can solve the problem. So the height is h. Okay, so this is a triangle. And oh, I don't know. We don't know the information yet. Okay, I'm gonna have to, I need to put a 3 here. So it's a 3. Okay, so this is a parallelogram. I know the length of each side, but without the further information, I cannot find the area. So I given the angle also. So if you're given the angle, this becomes a special triangle, and this is a h. Okay, this is 3. Okay, so according to the formula, right? And this is special triangle. So h is going to be square root 3 over 2 times the hypotenuse of the triangle. Okay, that's going to be 3. Okay, so that is h. So h, the height of the parallelogram. So once you get that, then the area is going to be the base BH. Okay, B is a 5, H is a square root 3 over 2. Okay, now let's more simplify this. 15 over 2, then times square root 3. So that is the area of the parallelogram. The key point is to find the H. Okay. Okay, good. All right, so now we continue applying the area formula for the the area from the triangles to other problems. Okay. Okay. So we are given, I think before we solve the problem, we needed to talk about the area formula for the equated triangle. For an equated triangle, if this is A, this is A, okay? I need the height. The height is going to be square root 3 over 2 times A, right? So the area is half of A times H. So it's half of A. H square root 3 over 2A. When I multiply this out, so this is our formula for the area of the equated triangle, if you know the edge length. All right. So we have a right hexagon. It's 10, yeah. The area of the right hexagon is 10 square meters. So what is the area of the ABC? Okay, let me draw the picture here. All right. So this is a hexagon. Okay. Okay. So this is ABC. A extended. Okay. Yeah, we are given the information of the area of the hexagon. We want to find the area of this little triangle over there. How can I do that? Now, I probably don't need the formula, but I just tell you, the area formula for hexagon is like that. Okay. What do you need to know is what you need to know is a right hexagon consists of 6 equated triangles. Hexagon, right hexagon, right? The angle here is each of the angles theta is going to be, first of all, it's going to be 360-degree total divided by 6. That's a 60 degree. Okay. And then those two angles must be same. So you can also figure out this angle is also a 60 degree because the sum of the 3 angles is going to be 180 degree. If this 2 angles we call the alpha, then theta plus alpha equals 180 degree. So what do you get? So it's 2, that's a 60, right? 2 alpha equals 180 degree. So 2 alpha equals 120 degree. Alpha is also 60 degree. So a right hexagon consists of 6 equated triangle. Okay. And that equated triangle consists of equated triangle here. Okay. So those two, this is a equated triangle, right? And these two triangles are same actually. You see, when you extend the two edges of the right hexagon, this is also 60 degree. That's a 60 degree. So that's a 60 degree. So those two, if that's O, right? So the triangle ABC is the same as the triangle we call it congruent, the triangle OBC, okay? Right? It's a congruent, that's the same. So the area of triangle ABC is going to be the area of the triangle OBC. And that's just equal to 1/6 of the area of the hexagon. Okay, so that's going to be 10/6. Okay, that's it. So 10/6, right? Okay. So yeah, this is a little bit difficult, right? So you what they do? Okay, step 1, you should know that the right hexagon consists of 6 equal triangle. Okay, that's the first point. Second point, the triangle ABC, okay, is the same, has the same size of the one of the 6 right triangles inside the hexagon. Okay, because that shares the same edge, right? They share the same edge. So in order to find the area of the triangle ABC, you just need to determine the area of one of the equated triangle inside the hexagon, which is 1/6 of the area of the hexagon. Okay, so it's clear step, right? Yes. All right, so now I wanted to figure out the next problem. So you are given a right hexagon, and each side is 3. Okay. What is the area? My hint, here's a hint. The hint is for an equal triangle, the area is going to be square 3/4 and times a squared. That's given, okay? So please do that problem and let me know what is get. Okay, I hope you already get the answers. First of all, you needed to draw extra lines, and you know the right hexagon consists of 6 identical equated triangles, right? So the area is going to be 6 times the area of each equated triangle, right? Then you know the formula, right? So equated triangle is 6, and here's square root 3 over 4 times a is 3 squared. Okay, so 3 squared divided by, you know, after simplifying, 6 is 3 times 2, right? Divide. Okay, so it's simplified. 27 and square root 3. Now do not approximate it. Okay, square root 3 is a number. Okay, perfect number, right? Then yeah, that's a perfect answer. You don't need to approximate unless you ask it to do that. Okay. So we already, you know, studied. We've gone through rectangles, triangles. Finally, we have to talk about circles. A circle, okay? A circle. What the information we need? We know the radius, right? We did not the radius, but then circumference. We already find out it's gonna be 2 pi r. Okay, this is probably where pi is defined. Area is going to be pi r square. Okay, those are the 2 formulas mathematician already discovered. Okay, and so pi is some number approximately equal to 3.141519. Okay, it can never be equal to 3.14. Remember, you can only say approximately equal to 3.14. And you cannot say pi is equal to 3.14. Okay, so in other words, if the radius is going to be 1, pi can be defined, can define the area of a unit circle. Okay, right? Because when I equals 1, you find out that the area is just equal to pi. So if we ask what is the value of a pi, then just say it is going to be area of a unit circle. The circle with the radius equal 1. It's half of the circumference of the unit circle also. So pi can be defined without the units here. Okay, is the area of circle without mentioning the units. Okay. There is an important property for the circle. If inside the circle, if you draw the diameter, okay, and that is going diameter, it's A and B. Now, if you take an arbitrary point C, that was it's interesting discovery. What we find out is this is always a right triangle. Okay, so if AB is a diameter, then the angle at C, is gonna be 90 degrees. Okay, that is very important. Yeah, that discovery. So it doesn't matter where the point C. So I think about this. I have AB here. Okay, another point here, right? So if I move to here, this is still 90 degrees. So you can do the experiment at home. You draw the circle and you draw the diameter in the middle, and you use a pencil and track, move around, around the semicircle, above semicircle. You will always get right triangle. Yeah. You can prove it later, but right now let's accept this fact. Okay, that's very interesting phenomena. It was discovered, by accident maybe. Yeah. So when some people make a circle here, draw the circle and put 2 nails, and you can do the experiment at home. Okay, draw the circle and draw the line passing through the center, and then this is the diameter. and you put the 2 nails at the 2 endpoints on the circle. Then use a string. Okay, use a string. And then you put a pencil here. You move the pencil. That's the point, right? Around the semicircle. You observe that you will see the triangle you're going to get is always the right triangle. Now it is discovered by you first. Maybe it's named after you. Okay, but of course it's already known by somebody. So right. So this is an interesting phenomenon. So in mathematics, sometimes, yeah, we get very interesting effects. Okay. It was not, probably discovered 100 years ago. All right. So let's take a look at this following problem. Okay. So let me draw the picture here. Otherwise, you don't know what they're talking about. All right. So we have something. Okay. This is a 24. Okay. 24. This side is 24. This side is 10. Okay. And also, this is a 90 degrees. So I have A, B, C, and D. Okay. And we want to find the area of the circle. Okay. So there is it's not a rect. It's not a. It is not necessarily be a rectangle here. I just draw. Okay, let me draw a slide differently. Okay, let me put. Okay, so think about this. Yeah, something like that. Okay, this is A. Okay, so the angle at A is 90 degrees. That's a picture you're given. What do we want to do? We want to find the area circle, but write down the formula for area circle. Area of the circle is pi r squared. So you have to find the r, right? You find the radius r. That's two-step problem here. Okay. And since we don't have much time, so let me finish it. Okay, step 1, you draw the line between C and D. Okay. So first of all, you conclude that BD is a diameter. Why? Because the angle is a diameter. Okay. Yeah, it must be done because since the angle at A is 90 degrees. Single at A is 90 degrees. Okay, it's a single at point A is again 90 degrees. Okay, that's the first statement. So once you find the diameter, then how do you find the diameter? Diameter is double of the radius, right? So diameter is D, and then the other side, this also implies the angle at C is also 90 degrees. Okay. Then the diameter D, right? Because by the Pythagorean theory, is going to be square root of 10 square plus 24 square. Okay. So which is going to be 10 is going to be 2 times 5. And 24 is 2 times 12 square. But I remember 2 can be taken out. It's 2. And then, actually it's going to be 12. Okay, it's 13. So it's 26. So 2 times 26. So that implies the radius is going to be 13. Okay, the radius is 13. Once you find the radius, then you find the area. Area is going to be pi times 13 square. It's 169 pi. Okay, 169 pi is going to be the area of the circle. So there was several steps involved, and yeah. So the key point is it's go back to the statement here. So I just said that AB is the diameter, then the angle at C is 90 degrees. Actually, this is a back forward. Okay. I needed to correct this statement. Otherwise, you cannot use that to prove this. Yeah. So that means if AB is diameter, then the angle at C is 90 degrees. But if angle 90 C is 90 degrees, then AB must be the diameter, just like if and only. So we have to use this fact to solve the next problem. And then go back to this problem, right? If the angle at the point A is 90 degrees, so that implies BD is a diameter. If BD is diameter, then the angle at C is 90 degrees. So go to the other side of it, go to the other triangle. If C is if 90 degree, then you can apply the Pythagorean theory to find the length between B and D, which is the diameter, and which is going to be 2 times 13, 26. Then once you get the radius, then you find the area. All right. So so we stop here, and wish you to continue study. And the next topic maybe not geometry, where we can study number theory. So you're going to get a set of exercise. I wish you find the time to do the homework.